Hello everyone, my name is Dennis. I'm the author of Chromatone, the visual music language that you can learn, explore, and express with. And today is mid of June 2024, and I want to just show you some progress recently made on the website as I kind of found new building blocks and start incorporating them into the main system. So let me go out of this flower, our beautiful flower that's already playing sounds and doing many beautiful things. So now I'm playing on my just regular computer keyboard, and yeah, there's already plenty of it, but maybe you already know this. What's new? What's new? I have a new synthesizer made here, ZZFX. Oh, I would need a cover picture here, but not much to cover because it's a tiny JavaScript synthesizer that's only 1 kilobyte in weight. So it's very efficient and it's quite simple. Okay, let me refresh the page. Yeah. So here we have this sound, and there is randomness, but it's including randomness and pitch. And this synth is very fast to get out of control. So if you, some things are pretty obvious. So attack, sustain, release. Yeah, you have long release, but then slide, just imagine. Yeah, so we're out of hand with this. And this synthesizer is more for different like effects that will, yeah, for game development, I don't know, for special effects. Yeah, and random. So Beat Crusher and all these effects are already embedded into this 1 kilobyte code. So probably should embed the code itself here, because if we go to the repository, you can just see it here. So this is the whole synthesizer. Imagine this. Yeah, that's all you need to play. So there's a buffer, and there are channel data and a bunch of math and random, and it's just fed into audio context and started. So we just play for some period of time. You cannot hold a note here, but maybe, and for sure, there are workarounds around that. So that's one thing. So if we want to go deeper, I can just start showing you the code itself. So let's go like this. And yeah, I want to open up my code editor, maybe make it bigger for you to easier watch. And yeah, let's go. So we go to content, practice. So we are in the Chromatone Center repository. I won't go deep and tell what is Git repository. And yeah, let's just look at this. You can find it on GitHub. I will hold the link somewhere in the description. So we go to experiments, and we go to oh no, we go to practice, we go to synth already, because it's not an experiment, it's quite working thing. So yeah, here we have the markdown file. That's about the page where we're at. So title, description, and yeah, let's make oh no, let's make a screenshot of this, of course. Okay. Yeah, of this, and this will be our amazing cover picture for here. So I will call it cover.png and go here and go to cover, again, cover PNG. So yeah, that's how we add the cover image to our page. Okay. And yeah, if I restart the development, so npm run dev, we will have our development server running locally, and it will show us everything that we've changed. So let's go to synthesis, and yeah, here we go, ZZFX. Okay, so what's here? We just import a component basically. So from just right there. So here's the component. Yeah, it's that simple. We have just rotary controls and MIDI keys. These are Chromatone default kind of common components that are used throughout the interface. And yeah, this is the thing. Yeah, it's small, so I made it even smaller. I mean, modular. Yeah, so we go to this JavaScript file. So it's storing this use ZZFX. I made it already this structured because I want to share it with people who want to use it straight up in Vue.js. Just use ZZFX, and that's all you need. You have unmounted, on before unmount, and watch your MIDI node that that the Chromatone itself provides. So we have limits for our knobs here, and we have some functions, helper functions like play node, and yeah, that's basically it. So we just need to change the sound and it will be played, as I believe. So there is this watch MIDI note play. No, that's it. So MIDI plays, and this is also MIDI. So down the bottom we have MIDI notes, and yeah, they are coming through the Chromatone internal MIDI system. Yeah, so this is one update, just recent, and yeah, most of others are experiments. So already some circles and lines there, but yeah, main thing is oh yeah, these are 4 experiments that I've created recently. So let's go look at them closer. So yeah, this is the last one that we are going to work today. So yeah, okay. Click anywhere, and yeah, you can create nodes, and you fly on such a glider. Yeah, and you can collide with walls and collide with nodes that are you can add and throw around and move around. And these are random, and they are created randomly out of current scale. So here is synth settings, global synth settings for Chromatone. You can change the scale. It won't change anything immediately, but next nodes will be coming out of this new scale. So this is a playground. I will change a lot here, but yeah, I like that you can kind of make a musical I don't know, labyrinth here. It's so interesting to just play around, especially with having all these going not through the default sounds of the website itself. I'm currently thinking about expanding this and making like having you like a choice to change the synth engine that's used throughout the website. Yeah, but the main thing is outputs MIDI. So all this is playing on this OPZ. So, oh yeah. So these are the same sounds, and it's going through effects and yeah, that's what makes it unique and so interesting to explore. So I can just add, you know, yeah, some beat going on, and probably beat and clock will be somehow introduced later. Yeah, that's how we go around it. Yeah, let's look at the code a little bit, and then I will show you around more. So we go to experiments, and we go to Matter. So it's a physical sequencer. I don't know what to call it, but Matter is the Matter.js library that I use. And yeah, here are some links to explore about it. And yeah, this is again only one component here. So we go to the component, and again, not much to look around here because I already can abstract things once I get them kind of okay, that are, working, and I I want to know what I'm giving to the component, and that's how you encapsulate. So then we have use matter, and yeah, but I wanted to know that I've done it twice. I disassembled it into modules, found it not useful and not comfortable, and packed it back. But now, yeah, I think it's the right modularity that I need. Let's introduce some entropy to the system, just to have it mixed around properly. Yeah, and turn down the volume. Okay, so we have this Matter.js simulation going on. So there's engine, there's zero gravity scale, and we create renderer that is just drawing this on the canvas with transparent background and no wireframes, but still with these lines to show the front. On dark you can see it much better. Let's turn dark mode, I think, for now. Yeah, yeah, this is the main part, I would say. So on mounted, everything starts happening. If not initiated, then we go, but say, so it runs once on the startup. We set up Matter.js, and we use center, that's our player triangle, and use circles, these bouncy things, and boundaries that are the walls around. So we just use these functions imported from separate files, modules, and yeah, this makes it quite manageable finally, because yeah, let's look at this center. So it's important bunch of things, and from main use matter we import engine, box, running, and renderer, probably, yeah. So we have this polygon center with big high density, and we added to the world that we're simulating. So, and we handle controls with pressed keys and set angular velocity and apply force when you just ah, every time you have control, we apply some force calculated from current position, angle, and adding some acceleration. So this is handle control in a loop, and handling the key presses. So that's very minimalistic, and we can just look back at the use Matter.js and the circles. What's interesting here is this collision start. So other than that, mouse control is very interesting to set up, and I'm glad to find all the places to listen to, all the events, and these collision starts, so we can define some logics and around this. So it's very interesting and creative. So this is Matter.js. It's just a template or starter pack and starter a project, and I would like to explore it more and more and create levels and maybe go out of boundaries and all this gravity and rep things that I've just commented out, but I love it. So I love this attractors that made me make these particles attract to each other and like behave like molecules or magnets, and matter wrap that moves them from one side to the other, like this asteroid feeling, because it's already this asteroid feeling. If I could like shoot bullets with nodes and move these around remotely, I would do that. I would stay in place and do this. And so it's so much fun, and it's like colors, music, and games all together. So let's move on. Next thing are these multiple pendulums. This is such a beautiful thing. I would make this a little less loud because we have more velocity here. And let's go look at the code. So this is pure mathematics. Again, we have markdown file that's importing our component, single file component, and all the code is here except pendulum class that's in a separate place, partially because it's copied from here. So Travis Taylor, thank you very much for this paper and overview, and we've built it and we've made it. Thanks. So now we are running this beautiful maths so in our view environment and SVG renderer. So this is all the math, and we even have to install and import quite a sizable Math.js just to functions, but it's kind of fine. Let me put down the volume a bit. I know. It's not about the volume, it's about the high frequencies. So what we have here is the main thing is tick and get coordinates. So we read coordinates and we receive this object, and we have to tick every once and then. So the code is all in one component, and let's look at it. So we import a bunch of things: pitch color, node names, a node from Tonal.js, MIDI things, our global scale that makes us again choose our scale and enjoy different sounding expression. So what I want to share with you is this very robust, flexible SVG setup. So we have a SVG and a box. Box is basically the place to store our size of this SVG, and there is this, and that's basically the number of nodes that we have in our scale. So if we have our 7 node scale, so let it be B Lydian. That's how it works. So very long chains of 7 nodes. Yeah, and this time it's shooted up very far, because when we start pendulums, we have used pendulum functions that again give us already consumable things. So we return coordinates and an active. So coordinates is the array of coordinates that we have to render. Active is its state of playing a note, and that's for making them bigger. So yeah, the scale thing. And coordinates is given by our computed. So this pendulum is built from the class. So we have n values, so we have the number of joints, and then we have random. So these are random angles, and every time we start it, we get new angles, and yeah, they can be quite steep. I should make a restart button. Maybe we will do it right now, because this simulation goes very well and very promising. We can go quite far with it, I think. Make it slower, make it faster, and that all happens just because we can choose the delta. So if we divide it more, we will go slower, and that's also kind of beautiful. And this is the theory of chaos. Every time there will be we have random. Even if we have same starting conditions, we will get different results, because it's a chaos evolving in small discrepancies of time, and everything that's a bit noisy in the computer will make it move differently, and every time the sound will be very different. Yeah, this is what I got after I was kind of inspired by physics. But in physics engines, you have all these dampenings, and the energy really dissipates, and such complex things will be hard to keep in motion, keep in right energy state. So it will be just like this, just mathematically perfect. So I came to mathematics, and yeah, we are going to our next experiment. Again, mathematics, very crazy, and I don't know, simple. So again, we go to numbers. You see these URL numbers corresponds to these content practice experiments. So practice experiments numbers markdown file, importing this view file. Yeah, so what do we have here? We have GISG. What is it? We have it is this beautiful foundation of online encyclopedia of integer sequences. So there are different sequences. So this particular is Fibonacci numbers. There's a quite simple formula to perform it and not a long list of nodes, but yeah, it's a long list of nodes actually. Yeah, so if you can choose, of course, some number of them and start generating. And then we have just simple interpretations of this number sequence. So we get a number, then we get it transformed to base 36, and this is the idea that we have like an octave below and 2 octaves above, so very wide, but still like possible range for some, I don't know, professional singer or guitar or yeah, quite any instrument. And then we can just play these notes, adding some this is like relative. Then we have our tonic note, and if we change it to other, yeah, so the notes changed. So let's do it in C. And then you can go to your favorite one. Yeah, and you can play numbers. Yeah, isn't it beautiful? Okay, I have my camera saying that I don't have much energy left, and we don't have, and maybe it's already half an hour. Yeah, so this will be first part. Almost, I would say that, yeah, I would just show you that one thing that I'm working on right now. So it's just very, very, very fresh. So it's just this. So this is like a minimal setup for an experiment. And again, this reactive box with resize as an observer help us maintain this shape consistently. Yeah, it's very robust, so we can go high, big projector or phone. Yeah, it should be quite stable. And I bet on this. And then we have just use stamp from UUs, if you know it, you love it. And that's it. So everything is happening in the template, and that's everything that's happening in the template. So these are commented out things from the pendulums. Maybe I would use some parts, but look at that. So rectangle is this shape around. So group goes for just the length of our scale, global scale, and +1. So we just go through, and yeah, we have circles that are positioned with these quite complex coordinates. So we have so why is this is to put them even and yeah, occupy this, and I have these paddings, so that's why I have +1 +2, and that's quite simple. But here we have cy is absolute value of a sine of time with this coefficient. So it's divided by 1,000 plus just 1, 2, 3, 4, 5, like this. And that's it. So that's the difference. But because the time is such a huge number, yeah, we have big differences. And yeah, we can just divide it by 1,000 and probably, yeah, yes, you see, this is less of a difference, but this bouncing pattern will be changing, and I really admire to, just look at this. That's beautiful, I think. Again, like no dissipation of energy in this system because it's just mathematically perfect bounce. So 100%. And that's ideal motion. That's what I think is very enjoyable. And yeah, I think in the next part, we will just explore this more and maybe add some controls, just touch controls, I don't know, and make it play music. Um, let's see how it goes. And yeah, stay tuned for more. These experiments are evolving and you can become a part of this because this is all open source. And yeah, welcome at Chromatone. See ya in the next part. Bye.